These are the notes for Math Essentials, Chapter 4, Section 7. We're talking about graphing inequalities with two variables, an x and a y. We put them into slope-intercept form first, which tells us that the y-coordinate is equal to the slope times the x-coordinate of that point plus the y-intercept. Y equals mx plus b. Now, the only difference is instead of an equal sign, we have these symbols. This is less than, greater than, less than or equal to, greater than or equal to. And the solution set will be a whole portion of the graph that makes it a true statement. First thing we're going to do is tell whether or not a point is part of the solution. To do that, we're going to plug in 2 for x and 0 for y. So instead of 3 times x, we're going to say 3 times 2 minus 4 times 0 is greater than 9. 3 times 2 is 6 minus 0 is greater than 9. 6 is not greater than 9, so that is not part of the solution. That point does not fall in the solution area. Let's try it again with 2 and negative 1. 3 times 2 for x minus 4 times negative 1. We want to see if that's greater than 9. 3 times 2 is 6. Negative 4 times negative 1 would be plus 4, and we want to see if that's greater than 9. 10 is greater than 9, so that is part of the solution. And what we do is shade the area that is part of the solution. First thing we want to do is put it into slope-intercept form. That means to isolate y, get y by get by itself. And remember to divide both sides by the same negative. If you are multiplying or dividing, you have to change the inequality sign. The boundary, graph the boundary line. Use a dashed line for less than or greater than, and a solid line for less than or equal to, or greater than or equal to. That means that line is also in part of the solution. It's kind of like when we did that before and colored in the circle. We had the circle here, and we colored it in. That meant that that number was also part of the solution. Test a point. We're going to find an easy point to test. See whether that is part of the solution of the inequality. If it is, we use that. We shade that side of the graph. If not, we shade the other side. Let's try it. We're going to graph this inequality. Y is less than negative 1/2 x plus 4. Start out with a y-intercept, which is at 4. 1, 2, 3, 4. And a slope of negative 1/2 means you go down 1 and over 2 to the next point. Down 1 and over 2 to the next point. Do it a couple of times. If we have 3 points on the line, we can get a more accurate line. If not, 2 is all we need, but 3 will make it more accurate. This says less than, y is less than 1/2, negative 1/2, so we're going to have a dashed line on here, just like that. And now we're going to see which we're either going to shade above or below the dashed line. So we're going to pick an easy point. Let's pick 0, 0. That's a very convenient point, and it's easy. If the line doesn't fall right on, go right through the origin, that's a good point. If it does, we'll pick another number like 1, 1. But a lot of times we can use that. What that means is that we say y, we're putting 0 in for y, is less than or equal to negative 1/2 times 0 plus 4. 1/2 times 0 is 0 also. So it says 0 is less than 0 plus 4, which is true. So that means that this side of the graph, where that point lies, is shaded in. Let's try a couple more. Now this one says x is greater than or equal to 3. So we're looking for all of the x-coordinates for 3. That means that it's going to be a vertical line here right at x equals 3. Because it's greater than or equal to, we draw a solid line on 3 in both directions forever. Now, what this means is that all of the solutions are more than 3. So our shaded part of the graph is going to be above 3, where the x-coordinates are greater than 3. This one over here, because 2 will divide into 6 evenly and 3 will divide into 6 evenly, we're going to find the x and the y intercepts, which is what we did before. So, 2, if we put 0 in for 2, 2 times 0 plus 3 times something is greater than 6. So we have 3y is greater than 6. Y is greater than 2, which means that the y-intercept is right here at 2. Now we're going to put 0 in for y, and we're going to say 2 times something plus 3 times 0 is greater than 6. So 2x is greater than 6. X has got to be greater than 3. And you know what? I made a mistake. That y needs to be on the y-axis, which should be right here. The x is on the x-axis, which is right here. And again, because it's greater than, it's going to be a dashed line. So we go just like that, in both directions forever. Now, let's see if 0, 0 is part of the solution. If you put 2 times 0 is 0, plus 3 times 0 is 0. We want to see if that's greater than 6. And 0 is not greater than 6, so that means that this part of the graph is not part of the solution. It's going to be the other side. There we go. Okay, y is less than negative 3. So now we're going to go down here on the y-axis and find negative 3, and then we're going to make a line. Again, because it's less than, our line is going to be dashed rather than solid. Now, if it says that the solution is less than negative 3, all of those answers are going to be below negative 3. Number 6 is another good example of a way that we can use the x and the y intercepts, because 3 will go into 6 evenly and so will 2. So we're going to put 0 in for y. 3 times x minus 2 times 0 is greater than or equal to 6. 3 times something is greater than or equal to 6. Because 2 times 2 is 0, it's totally gone. So x is greater than or equal to 2. Go over here on the x-intercept, or the x-axis, to find the x-intercept, which is at 2. Now we're going to put in 0 for x. 3 times 0 minus 2 times something, whatever y is greater than or equal to 6. That's gone. Negative 2y is greater than or equal to 6. Remember, when you divide by a negative, we change the sign. So y now is less than or equal to negative 3. Come down here to 1, 2, 3, negative 3. Because it is greater than or less than or equal to, because of this line underneath here, it's going to be a solid line. So there's our line that goes in both directions. Now, let's see if our point here, this 0, 0, is part of the solution. 3 times 0 is 0, minus 0 is greater than or equal to 6. Is 0 greater than or equal to 6? No. So that is, this part of the graph is not part of the solution. that means this part over here is part of the solution. Okay, we only have 2 more graphs, so let's try them. Again, because 4 and 2 will both divide nicely into, let me see if we can get it. There we go. Where we can see it. You can divide 4 into 8 and 2 into 8 evenly. Then we're going to find the x and the y intercepts. So 4x is greater than or equal to 8. Notice that I completely left that out because it's just 2 times 0. It's 0. So x is greater than or equal to 2. That means it crosses the x-axis right here at 2. Going to do the same thing when I put 0 in for x over here. Negative 2y is all that's really left, is greater than or equal to 8. So y, switch the sign, is less than or equal to negative 4. 8 divided by negative 2 is negative 4. Go down here, 1, 2, 3, 4 on the y-axis, and we're going to connect the dots. This time, our line will be a solid line because it's greater than or equal to. Now, let's see if the origin fits in, our number here. 0 minus 0, that means 0 greater than or equal to 8. Nope, that part is not part of the solution. So this area down here is going to be part of the solution. That's the side that is shaded in a little bit. Again, 3 and 2 will go into 6 evenly, so we'll find the x and the y intercepts and then decide which side of the line to graph. Let's see if we can get it. There we go. Okay, so if I put 0 in for y, we don't have to worry about that anymore, and all we have to know is that 3x is less than 6, so x is less than 2. That means it crosses the x-axis at 2. Now if we put 0 in for x, we're left with 2y is less than 6, or in other words, y is less than 3. So it's going to be up here on the y-axis on number 3. Because it is less than and not less than or equal to, our line will be a dashed line, just like that. And it goes in both directions forever. Let's see if our point works. 0 plus 0 is less than 6. Yes, that works. So that means that the numbers on this side of the line are part of the solution. And then ones on the other side are not. Again, what we've got is an infinite number of solutions. What this means is everything in this area is part of the solution, not just the line. We're kind of restricted to the line if it's an equal to, but if it's less than, that whole area is part of the solution. If you have any questions, come talk to us. We'd be glad to help you with this. Thank you very much for listening.